Good evening. This is Mrs. Bolin with the University of West Florida. This is the lecture for College Algebra 5.6. And we're going to be going over rational functions. So if you joined me earlier today, look for a message at the very beginning. I'm going to probably try to edit a message in that, or I'll send it out in an email that says fast forward to such and such a time, because you already learned most of this, and evidently when we did this morning, I inserted the notes twice. So we were only one problem away from actually finishing. So that was encouraging to me once I realized that. All right, here we go. Rational function is simply one polynomial divided by another polynomial in this form, where the q of x, which is in the denominator, obviously cannot be equal to 0, or we will have an undefined function here, or undefined situation. Okay, so the domain of a rational function includes all real numbers except those that cause the denominator to equal 0. So the domain is going to be all real numbers minus the numbers, or removing the numbers that would make the denominator equal to 0. So exercise 1 here says find the domain of the rational function. Remember, I told you the very first week of class that we would be finding the domain throughout the entire semester. I keep my word, and here we go again. Okay, and it says give your answer in interval notation. So here's our function. It says f of x is equal to x squared plus 2 divided by x minus 7. So to find the domain, we start off with our domain bucket. There's our domain bucket right there. And in our domain bucket, we have all real numbers. And we're going to throw out whatever numbers, we're going to remove whatever numbers from the set of all real numbers that will make this denominator right here equal 0. So I want to say that x minus 7 cannot equal 0, because when it does, we have a problem. So we'll add 7 to both sides, and we'll get x cannot equal 7. So the number that we're going to throw out is 7. So the domain consists of all real numbers except for the number 7. So if I were to draw a number line, our domain would look like this. We would take and we would say our domain cannot equal 7, but it's every other number in the real number system except for the number 7. Okay? So let's write that in interval notation. So the domain is negative infinity to 7 union 7 to positive infinity. We're going to jump over the number 7. Let's move on to example 2. Find the domain of the rational function. Give your answer again in interval notation. Again, we're going to look at the denominator, and we're going to examine that and look for the domain and saying that x squared plus 10x plus 9 cannot equal 0. I'm going to change the color of my highlighter here. There we go. I like that better. So I think you all can see through it a little bit easier. So we're going to say x squared plus 10x plus 9 cannot equal 0. So we're going to factor this out. We're going to take our x, we're going to put an x there, an x there. Our factors are 9. We have a positive and positive, so we know that both of those are additions. And if I did 3 and 3, that would only add to 6. So I needed to use the factors of 9 and 1 because they have to add to 10. And this cannot equal 0. Okay? So again, in that case, we're going to let each factor, we're going to set it saying that x plus 9 cannot equal 0, and x plus 1 cannot equal 0 when we're looking for the domain. So therefore, x cannot equal negative 9, and therefore x also cannot equal negative 1. So we're going to draw a number line, and we're going to put down our 0. We'll put negative 1, negative 9, and we're going to say that we cannot equal 9. And we can't, or negative 9, we cannot equal negative 1. We have an open circle because of that. So our domain is all the other numbers. And so that's what our domain is going to look like. So let's write our domain in interval notation. So our domain, domain is going to be from negative infinity to negative 9, union negative 9 to negative 1, union negative 1 to positive infinity. And that's how we write it in interval notation. Now we're going to talk about asymptotes. Asymptotes are very important in the process of graphing any rational function. We have horizontal, vertical, and slant asymptotes. Another name for slant asymptotes is the oblique. I prefer the name oblique because it's just more of a typical math term. But I will do my best to use the word slant asymptote. If I should slip up and use the word oblique, though, you'll also now know what it means. So we have horizontal, vertical, and diagonal lines. Diagonal lines would be the slant or oblique asymptotes that are a graph approaches. The graph will never cross a vertical asymptote, but it can touch or even cross a horizontal or slant asymptote. It's very important that you realize that a vertical asymptote cannot be crossed or touched, but if it is a horizontal or an oblique asymptote, your rational function can cross and it can touch those asymptotes. So we have some rules here on how we find our asymptotes. So our rules for finding a vertical asymptote is this. Step 1, simplify if the numerator and denominator have a common factor. So remove any common factors. Step 2, set the denominator equal to 0 and then solve for x. To solve for our horizontal asymptote, step 1, we're going to examine the degree of the polynomial in the numerator as well as the denominator. And we're going to use that information to determine if we even have a horizontal asymptote and what it's like. So if the degree of the numerator is greater than the degree of the denominator, then there is no, okay, if it's, then there is no horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, then our horizontal asymptote is the x-axis, y equals 0. If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is a ratio of the leading coefficients. So you have to be able to pull off those leading coefficients. So let's look back at example 1 right here, and let's see what would be a horizontal asymptote. So it says our degree here is 2 and our degree here of the denominator is 1. So the numerator is greater than the denominator, which is the scenario here. The degree of the numerator is greater than the degree of the denominator. It says there is no horizontal asymptote. So for this problem right here, there is no horizontal asymptote. Let's look at problem number 2. This one right here. The degree of the numerator is 1. The degree of the denominator is 2. So the degree of the numerator is less than the degree of the denominator because 1 is less than 2. So our horizontal asymptote is y equals 0, which is also the x-axis. Alrighty. Let's look at our slant or the oblique asymptote. So our slant or our oblique asymptotes occur when the polynomial of the numerator is higher than the degree of the denominator. So to find a slant asymptote, we use long division or synthetic division, and the quotient will give the equation of the slant. So let's find the vertical and horizontal asymptotes of the rational functions. So the first thing I want to do is find the vertical, and then I want to find the horizontal. So our steps for finding the vertical asymptote. So to find our vertical asymptote, step 1, remove any common factors. There are no common factors. Step 2 is in set our denominator equal to 0 and solve for x. So we're going to have x plus 2 equals 0. Therefore, our vertical asymptote is x is equal to -2. So that's our vertical asymptote. Looking at our horizontal asymptote, we need to know what the degree of the numerator is. Our degree of the numerator, so the degree of the numerator is equal to 0. Okay? Remember that 5 times x to the 0 power is the same thing as 5 times 1, which equals 5. So the degree of the numerator is 0. Now we need to look at the degree of the denominator. So the degree of the denominator is equal to 1. Okay? So if we go back, so the degree of the numerator is 0, the degree of the denominator is 1. We're going to go back and we're going to say the degree of the numerator is less than, that's 0, is less than the degree of the denominator, which is 1. Therefore, our horizontal asymptote is y equals 0. So it is y equals 0 is the horizontal asymptote. Okay, so that's what we were supposed to do for part A. So now let's look at part B. So we're going to just kind of go like that. Okay, so for part B, again, to find the vertical asymptote, step 1, remove any common factors. Even though there's a 7 here and there's 7s down there, there is no common factor. So there's nothing to simplify out. So step 1, no common factors. And step 2 is we're going to take the denominator, we're going to set the factors equal to 0 and solve, or actually say, and solve. Okay, so then we have x plus 7 equals 0, x minus 7 equals 0. Therefore, our vertical asymptotes are at x equals -7 and x equals +7. I want to bring that over. So it's positive and -7. Okay, so the vertical asymptote is that x is equal to positive and -7, just solving both of those. Coming into our horizontal asymptotes, so our horizontal asymptote, we need to know the degree of the numerator, and that is equal to 1. We need to know the degree of the denominator, and that is equal to 2, because x times x is going to give me an x squared, so that is going to be 2. So the degree is 1 in the numerator, degree of the denominator is 2. So again, we're in situation 2 where the degree of the numerator at 1 is less than the degree of the denominator, which is 2. So our horizontal asymptote is y equals 0. So therefore, our horizontal asymptote is equal to y equals 0. All right, we're going to look at part C next. Okay, part C. So we're going to first do our vertical asymptotes. Step 1, are there any common factors? Well, I don't know yet, so I need to look at this. So let's go ahead and factor out. We have x plus 2 in the numerator. We're going to factor out our denominator here, and we're going to have it like this. And we're going to have an x and an x, opposite signs because of the negative there. This is 3. It's a prime number, so we're going to have a 2 and or a 3 and a 1. And our 3 needs to be positive, and our 1 will be negative. Okay, so I do not have any common factors. So we're going to write down no common factors. Step 2, we're going to set the denominator equal to 0. X plus 3 equals 0. X minus 1 equal to 0. And we're going to solve. So this is x is equal to negative 3. X is equal to 1. So my vertical asymptotes occur at x equals 1 and x equals negative 3. Now I need to find my horizontal asymptotes. So my horizontal asymptote is going to be here. So we're going to put horizontal asymptote. I need the degree of my numerator. That's going to be 1. I'm going to need the degree of my denominator. That's going to be 2. So 1 is less than 2. Same scenario as over here. So we know that our horizontal asymptote is y is equal to 0. And I'm going to kind of go like this so my workspace is divided here. And now I'm going to solve part D. And for part D, I'm going to start right here. So I'm going to solve my vertical asymptotes first. So step 1, remove common factors. So I need to look at this. I'm going to factor my numerator and my denominator. So my numerator is I have x and x, a positive and positive. And 15 is going to be 5, and 3 is going to give me 8. So there's my numerator factored. Now I'm going to factor my denominator. Put down my parentheses, my x's. I have a negative there, so I know I have opposite signs. My factors of 6 are going to be 1 and 6. That won't give me a difference of 1. And then 2 and 3, and that will give me my difference of 1, where my 3 is going to be positive, and my 2 is going to be negative. Okay, so now I'm going to look, and you can see here that I do have common factors right there and right there. They're going to cross out. So then what I have left is 5, or x plus 5 divided by x minus 2. So when I come in here, it's going to be, our results will be x plus 5 divided by x minus 2. So x minus 2 equals 0. Therefore, my vertical asymptote is at x equals 2. Now I need to find my horizontal asymptotes. My horizontal asymptotes is I need the degree of my numerator and that is going to be equal to 2. Then I need the degree of my denominator, and that is equal to 2. So I have equal degrees. So when I have equal degrees, that's number 3 right here. And it says then the horizontal asymptote is the ratio of the leading coefficients, okay? And so the ratio of my leading coefficients look like this. Not my degrees, but my coefficients. What's my leading coefficient for the numerator? Is 1. What's my leading coefficient of my denominator? It is also 1. So my horizontal asymptote is going to be y is equal to 1 divided by 1, which is equal to 1. Alrighty, moving right along. It's been a long day, so I'm sorry if I'm dragging a little bit. Example 4, it says find the slant asymptote of the rational function. So here we go. Because the degree of the numerator right here is greater than the degree of the denominator, we know that we have an oblique or slant asymptote. In order to solve that, we will use synthetic division. And so I will go x plus 5 equals 0. Therefore, x is equal to negative 5. Okay. So I have negative 5. I'm going to pull off my coefficients. It's 1, negative 6, 7. Put my placeholder. I'm adding, going straight down. 1 plus 0 is 1. 1 times negative 5 is negative 5. Negative 6 plus negative 5 is negative 11. Negative 11 times negative 5 is a positive 55. 55 plus 7 is 62. So coming in, I have this is x squared, x to the first, x to the 0, x to the first, x squared, and there's my remainder. So for the equation of the asymptote, we actually do not use the remainder. So everybody in class kind of pay attention. That was on the notes earlier today. We don't use the remainder. So the equation for the asymptote, the oblique, is just going to be x minus 11. Okay, and that's going to be it. Do not use the remainder. For the slant asymptote. Well, if it'll write. There we go. There we go. Alrighty. All right. So one of the other things that we need to do is find the x-intercepts, y-intercepts, and we need to be able to graph our function. So here we go. We need to find the x and y intercepts. This is counterintuitive, okay? So finding the x-intercept, the first thing you have to do is simplify the numerator and the denominator and remove any common factors. Then you set the numerator, not the denominator. Your intuition is going to be do the denominator. It's not. It's the numerator. Make sure you set the numerator equal to 0 and solve for x. And then to solve for the y-intercept, it's just like we always do. Plug in x equals 0 and solve. So for this one right here, for part A, it says find the x and y intercepts of the rational function. Step 1 for the x intercept. Step 1, remove common factors. There are none, okay, so there's nothing to remove. So step 2 then is set the numerator 4x minus 8 equal to 0 and solve. So we will add 8 to both sides and we get 4x is equal to 8. Divide both sides by 4, therefore x is equal to 2. So our x-intercept is the point 2, 0. Now I need to solve for my y-intercept, and so my y-intercept is going to be the point 0 something. I don't know what that something is. But we're going to plug it in and we're going to say f of 0 is equal to 0 minus 8 divided by 0 plus 8, which is going to be negative 1. Okay, so that is our x-intercept. Now we're going to find our y-intercept. Now we're going to find our x-intercept and our y-intercept of the next problem. So for part B, we're first going to find the x-intercept. And that's going to be a point and 0. And the first thing I have to do is remove any factors, common factors. So I want to put my numerator in factored form. So I'm going to end up with x and x. I have a positive and positive, so that's going to be plus and plus. 7 and 1 divided by, looking at this, x and x, negative, so I'm going to have a positive and negative. And now it's going to be a 7 and a 3, and my 7 is going to be positive because my 4 is positive. So 7 and 3. And when we look at this, then we can see that we have this and this factoring out. So that leaves me with step 2 of x plus 1 divided by x minus 3. Therefore, we're going to take x minus 3 equal to 0. X is equal to 3. So that is our x-intercept. Now we need to solve for our y-intercept. And when we do our y-intercept, we're going to do y-intercept. And we're going to have a point 0 and something. I don't know what that something is yet. And in order to solve that, we're simply going to substitute in the number 0 for x wherever it occurs. So we're going to end up with 0 plus 0 plus 7 divided by 0 plus 0 minus 21. Because 0 squared is 0, 0 times 8 is 0, 0 times 4 is 0, 0 squared is 0. So I end up with a negative sign 1/3. Okay? And so my y-intercept is negative 1/3. Alrighty, now I need to be graphing my functions. So to graph our functions, the first thing we're going to do is draw the vertical and horizontal asymptotes. Then we're going to plot the x and y intercepts, and then we're going to plot at least 2 points on each graph. And our instructions are to graph these points, or those graphs. And this is our last few things that we're going to do. Alrighty. Oh, my sons are cooking supper and they just gave me a 5-minute warning, so I don't know that we'll wrap this up in 5 minutes, but I'm trying hard. Okay, here we go. Alrighty, it's been a long day. So, first thing it's said to do is draw the horizontal and vertical asymptotes. So let's go ahead and calculate our vertical asymptotes first. So our vertical asymptote, step 1 is where we remove any common factors. There are no common factors. Step 2 is for our asymptotes is we're going to say negative x plus 3 is equal to 0. Subtract 3 from both sides. We get negative x is equal to negative 3. Multiply both sides through by a negative 1, and therefore I get x is equal to positive 3. And that is my vertical asymptote right there. Okay, so I'm going to plot that as a vertical asymptote, positive 3. I do dotted lines for my asymptotes. Next one I'm going to do is going to be my horizontal asymptote. Okay, so I need to know the degree of my numerator is equal to 1. The degree of my denominator is equal to 1. I have equal degrees, so you guys, you're going to have to memorize this. I forgot to talk to you about that. The rules, especially these right here, you have to have that memorized for your exam, okay? You're not going to be able to have it written down. We are going to have the lockdown browser. You're going to have a camera watching you, and so it's just not, you're just not going to have access to that information, and you have to have that memorized. So make sure you have that memorized. And in addition, there's going to be an app. I'm going to send out information on that soon, and you will be, if you want to, you don't have to do this, but if you would like to have your work considered for partial credit, you'll have 15 minutes using an app to send me your work, okay, so that I can look for partial credit. Okay, so, kind of forgot where we were at on this. So let me go back down and see what my degrees were. They were equal. So with them being equal, that is going to be the third option right here. If the degrees are equal, then the horizontal asymptote is the ratio of the leading coefficients. So let's come back here, and my leading coefficient for my numerator, so my horizontal asymptote, then my horizontal asymptote is going to be -2 divided by, so it's the leading coefficient divided by the leading coefficient, which is -1. That is going to equal a +2. So y is equal to 2 is my horizontal asymptote. And so that goes like this. Okay. The next thing we want to do is do our x and y intercepts. So our x and y intercepts. So our x-intercept is going to be something, 0. And to calculate our x-intercepts, the first thing we want to do is remove any common factors. There are no common factors. Step 2, we're going to set the numerator equal to 0 and solve. So it's -2x plus 4 equals 0. Subtract 4 from both sides. We get -2x is equal to -4. Divide both sides by -2. And we get, therefore, x is equal to a +2. So our x-intercept is going to be the 0.20. So the 0.20. Okay? The next thing we're going to do is we're going to do the y-intercept. So our y-intercept is going to be the 0.0 something. And we're going to calculate that by plugging in 0. So we're going to end up with 0 plus 4 divided by 0 plus 3, which is going to be 4/3, which is also 1 1/3. So that is going to be the 0 and 4/3. So 0 and then 4/3 is going to be right about there. Okay. Now the next thing we need to do is it says plot at least 2 points on each section. So I need to plot 2 points using values in here, okay, and then 2 over here. So I already have 2 right here, and I'm just going to use those 2. And it will tell me then that my shape of my graph is like this. What I don't know is what's happening over here. Is it up here or is it down here? Okay, so I will come in and I will say, okay, I need to make a chart of when x is greater than 3. So x is greater than 3. I need 2 values of x to determine what's going on, and I'm going to pick the values of 4 and 5. 2 values greater than 3. I'm choosing whole numbers 4 and 5. So I literally am going to evaluate what is f of 4. So that's going to be -2 times 4 plus 4 divided by -4 plus 3. So -2 times 4 is 8, -8. -8 plus 4 is -4. -4 plus 3 is -1. So that is equal to +4. So when I plug in a 4, I get out a 4, and that is going to give me a point right there. The next one I need to evaluate is f of 5 right there. And so I get -2 times 5 plus 4 divided by -5 plus 3. So that's going to give me -10 plus 4 divided by -2. -10 plus 4 is -6. -6 divided by -2 is a +3. So this is a 3. So I have the 0.5 and 3. and it is right here. And so I know then that my shape is going to look like this. And that is how I graph that problem right there, problem number 1. Moving on to problem number 2. Again, we're going to graph it. We're going to start off with our asymptotes. So I want to identify my vertical asymptotes. My vertical asymptote is going to be equal to, I need to look and see if there's any common factors. Okay, so step 1, I'm going to factor my numerator. So I'm going to get x and x. I'm going to have a positive and a negative. And then I'm going to have a 3 and a 4. My 4 is going to be positive. My 3 is going to be negative. And then my denominator is x plus 2, x minus 2. And when you look at this initially, you're like, ooh, this is going to definitely factor. But when you look at it, after you actually do the factoring, you see there is no common factor, okay? So there is no common factor. Okay, so now we're looking for vertical asymptotes. So our step 2 is we're going to take the denominator, we're going to set it equal to 0 and solve for x. So we have x plus 2 is equal to 0, x minus 2 is equal to 0. So therefore, x equals positive and negative 2. So we end up with x is equal to positive and negative 2 for our vertical asymptote. So that means I have a vertical asymptote right here. That was a little bit sloppy. That's all supposed to be on a 2. Negative 2, like so, and like so. Now I'm going to look at my horizontal asymptotes. And I'm going to look at the degree of my numerator. My degree of my numerator is equal to 2. My degree of my denominator is equal to 2. So I have equal degrees. So when I have equal degrees, we come back up. And it says when I have equal degrees, I'm going to have a ratio of the leading coefficients. So we're going to come back and we're going to look at the leading coefficients and get our ratio. So a horizontal asymptote is going to be, leading coefficient here is 1. Leading coefficient here is 1. 1 divided by 1 is just 1. So we end up with y is equal to 1 as our horizontal asymptote. So we're going to sketch that in right now. Okay, so now I have my horizontal asymptotes and my vertical asymptotes, and so the next thing we're going to do is we are going to solve for our x-intercepts and our y-intercepts. So our x-intercepts, our x-intercepts look like this. I've already used that color, so let me choose a different color. So our x-intercept, it's going to be some point 0, right? Okay, so to solve this, the first thing we have to do is remove any common factors. We already assessed that right here. There are no common factors. So now we're going to look. So number 1 says no common factors. Step 2 says we look at the numerator and we set it equal to 0. So I have the numerator is x plus 4 and x minus 3. So I'm going to set each factor equal to 0 and solve. So x is equal to negative 4 and x is equal to positive 3. So actually I have two x-intercepts. One is at negative 4, 0 and 3, 0. Okay, I need to plot both of those. So 3, 0, I have one right here. And then the other one is negative 4 and 0, and that is right there. Oops, my 3 disappeared. There we go, we got it back there. Okay, now I need to do my y-intercept. My y-intercept is going to be right here. Y-intercept it's going to be 0 and then a number. And we're going to solve that by plugging in 0. And we know this goes to 0, this goes to 0, so I get negative 12 divided by that goes to 0, and then negative 4. So negative divided by negative gives me a positive 12 divided by 4 is 3. So the point 0.03 is my y-intercept. The last thing I need to do is I need to have 2 points in each section here. Okay? And so when I do that, I'm going to come over here and I'm going to say, well, when x is less than 2, or negative 2, x is less than negative 2, I'm going to have an x and a y. I already have one value, so I'm just going to pick one more. Let's look at negative 3. So f of negative 3 is going to be equal to negative 3 squared is 9 minus 3 minus 12 divided by negative 3 squared again is still 9 minus 4. So 9 minus 4 is 5. And then 9 minus 3 is 6. So 9 minus 3 is 6 minus 12 is going to give me a negative 6. So that's like negative 1.2. Oops. Yep, negative 1.2. So negative 1.2. So the point negative 3, negative 1.2 is going to be right about here. And so that tells me that my graph looks like that and that part right there. Now I have 1 point in here. I need another point right in here. I'm going to choose the point 1. So the next spot that I'm going to look at is when negative 2 is less than x, which is less than positive 2. So I'm going to have an x and I'm going to have a y, and the value for x I'm going to choose is 1. And so I'm going to plug in, I'm going to say f of 1 is equal to, well, it's going to be 1 squared, which is 1, plus 1, that makes 2. 2 minus 12 is negative 10. And then again, 1 squared is 1. 1 minus 4 is going to give me negative 3. So I end up with a positive 3 1/3. So negative or positive 3 1/3. So 1 and then 3 1/3 is like this. And I'm going to find that this looks something like this. And then the last one that I need to do is one more over here. We'll look at the point 4. And let's grab some ink right in here. Let's look at this right here. And we can say we're going to evaluate when x is greater than 2. And so when x is greater than 2, I need to find just one more point because I already have one. I'm going to choose the point 4. So f of 4 is equal to, so 4 squared is 16. 16 plus 4 is 20. And then 20 minus 12 is going to give me 8. So it's going to be 8 divided by, again, 4 squared is 16. 16 minus 4 is 12. So 8 divided by 12. 4 will go into 8 2 times, and 4 will go into 12 3 times. So that is 2/3. So we have 2/3. So we have the point 4 and 2/3, which is right about here. And so we now know that this is going to be this on shape. Alrighty, one last problem to go, and then we are done. Alrighty, it's been a long day. First thing we want to do is determine our asymptotes. So our vertical asymptotes, remember step 1 is we're going to remove common factors. So we're going to have a factor here, x and x. We're going to have a negative and a positive, And we're going to have 2 and 4, where my 4 is positive, my 2 is negative. My denominator is going to be x and x, positive and negative. And then my 5 is going to be positive, my 1 is going to be negative. I do not have a common factor, so there's nothing here to reduce, so no common factor. Step 2, because I'm looking for vertical asymptotes, I'm going to look at the denominator. I'm going to say x plus 5 equals 0, x minus 1 is equal to 0. Therefore, x is equal to negative 5 and positive 1. So my vertical asymptote is x is equal to negative 5 and positive 1. So negative 5 is going to be right in here. And then positive 1 is going to be right in here. Then we have the next thing I need to look for is going to be my horizontal asymptote, my degree of my numerator is 2, my degree of my denominator is 2. They are equal, and when they are equal, that means that I have the leading coefficient, the ratio of the leading coefficients, and my leading coefficients are 1 and 1. So my horizontal asymptote is going to be y is equal to 1 divided by 1, which is 1.